Okay. Can you hear me now? Okay. I'm sorry that my internet was disconnected.
Yes, we can hear Doctor.
Boleh tapi
Okay, right.
putus tu.
Uh, okay.
Terputus.
Let proceed. Okay. I know. Right. Okay. Okay. Let let me summarize a little bit. Okay. When you want to calculate the energy, you express all the term in term of secular determinant. Okay. Secular determinant is where the determinant equals to 0. And then when you express this thing and then you exploit autonomality condition, SAA equals to 1 and SBB equals to 1, the secular determinant can be simplified, okay? Which one? Okay, sorry. SAA becomes 1, okay? And then SBB becomes 1. So this is what you get, okay? And then how to solve this secular determinant? It is very, very easy, okay? This thing multiplied by this thing, and then minus this thing multiplied by these things, okay? So you multiply the diagonal term, and then you minus the off diagonal terms, okay? And then this is what you will end up. So if you look at this thing, okay, there are some facts that you need to know, okay? At equilibrium distance RE, HAB is negative, okay? So this one is negative. This one is negative, okay? So if you look at this term, okay, you would expect E1 or EG is much lower than E2 or EU, okay? Why? Because this value is minus, okay? So you would expect this value to be small. And then this value to be large, okay? Because it is minus minus, which is positive. So this one is large. But if you look at some fact, okay, positive energy means that the molecule is unstable, okay? So you want to find the energy as minimum as possible. That is why if the term here is small, okay, like you have 1 divided by 10, okay, you get 0.1, it's very small, okay. It is much better, okay. And then we refer psi g to bonding orbital and then psi u as anti-bonding orbital, okay. Okay, let's me summarize today's lecture for this hydrogen molecule ion. Upon Oppenheimer approximation states that you can split or separate the wave function into electronic part and nuclear part. Why? Because the nucleus is much heavier than electrons, okay? It is 2,000 times much heavier than electrons. Molecule form because total energy is smaller than the individual atoms, okay? That is how you form molecule. And then molecular orbital theory, MO theory, okay? First, it expressed the wave function using molecular orbital. These molecular orbital are constructed from linear combination of atomic orbital, okay? And then overlap integral S characterize the extent of overlap of atomic orbital, okay? The energy can be calculated using a secular determinant. So I would expect you to know how to calculate the energy from secular determinant, okay? Secular determinant is when the determinant equals to 0. And then the final fact is that lower energy means a stable molecule, okay? So you want to minimize or lower the energy as much as possible. Okay, okay. So for that's it for today's lecture. So I hope I know it is a bit it's a bit heavy to you to digest and understand this thing, but it is not so much difficult. Okay, so because you you use this molecular orbital theory, okay, to explain the formation of molecule from the individual atoms, okay. But I think the take-home message is that you can use all those atomic orbital, okay, uh, to form you express it as a linear combination and then to form the molecular orbital, and then you can calculate the energy, okay. What is important is that you know which one has lower energy, okay? Which wave function has lower energy, and then which one has higher energy, okay? And then lower energy meaning that it is stable, okay? Higher energy meaning that it is unstable, okay? That's it for today's lecture, okay? Uh, Thank you very much for your attendance and attention. Okay.